All right. Hey, everybody. So today I want to start first by talking about your homework. So when you log into Blackboard, I have this tab here called Homeworks. And if you go back and look at the syllabus, you'll see that we have 7 graded homework assignments. And your first homework assignment is actually due next Thursday. So if you go to the Homeworks tab here, I posted your first homework. So I posted it 2 ways. I posted it as a PDF file. So what you can do with the PDF file is you can download and print the PDF file and like write in your answers if you want to. Or I have a Word document here. And what you can do is you can download the Word document and type in your answers and then just save the Word document. I would accept either one of those. I also realized maybe people, they might have a printer, but they don't have a scanner. So what you can do is you can take pictures with your phone if you have to and submit the pictures. But there's just like certain iPhone formats of pictures that I can't open. And then I also can't open like .page files, .pages. So just make sure you can submit it. You submit it either as a PDF, a JPEG, or a document file that I can open. All right, so the way you'll submit it, once you have your homework completed, you'll just go click on the assignment here. You'll scroll down to browse my computer, and then like wherever your file is, you'll just click on it, and then you'll just hit submit. Okay? And you just have to have that in by next Thursday by 11:59 p.m. Eastern Standard Time. So as long as it's in before then, you're good.
I have a question.
Sure.
If we have any questions on the homework, like for stuff, do we just join your
Office hours?
Yeah, office hours?
So you can do one of two things. You can join my office hours, and I'll share my screen, or we can video chat and I can go through it with you, or you can just shoot me a quick email. And a lot of times, a quick email, I can answer your questions that way.
Okay, thank you.
But either one is fine. So for your homework today, after class today, you'll be able to answer questions 1, 2, a little bit of a typo there. Sorry, I have 2 question 2s. 1, 2, 2. You won't be able to do, you might be able to do question 3 here. Something about the mean, median, and range are pretty easy, but the standard deviation might be new. We're going to cover that next Tuesday. And then you'll be able to answer this question too on the homework, right after class. So I actually encourage you after class to try the homework and get it done ahead of time instead of waiting, while this stuff is fresh in your mind. And then I'll be checking my email a bunch over the weekend if you have any questions. All right. So before I start the lecture, does homework seem straightforward?
Yes.
Okay, you should. I'll be honest with you. This first homework is probably the easiest one. So, get it done early. Get it in. You'll probably be able to score very well on it. And then if you have any questions, just let me know over the weekend. All right. So let's get started. And I want to start kind of class today with a little bit of a review from last week, or from last class. Okay, and I want to go over something I went really, really quickly with. And this was about data types, because we're going to be talking a lot about, can't spell, different types of data. Geez, I'm just having a blank here today. Different types, data types. If anybody remembers, does anybody remember initially how data was classified? It was classified as one of 2 ways. There were 2 different keywords. I know I went through it pretty quickly.
Was it discrete?
Before that.
Oh.
Yep, right there in the chat. So the way you initially defined data was it was either qualitative, I misspelled that too, or quantitative. Okay. And qualitative data, if you remember, these were categories, okay, that you could fit people into. Like an example of a qualitative data was someone's eye color. Like I fit into the category of people who have brown colored eyes, okay? Some of you might fit into the category of people who have blue colored eyes. Quantitative variables here, these were numerical measures. And then quantitative variables, if you remember, we could break that up as, what were the other ways that you could break up quantitative variables? This someone was just saying, yep, there was discrete and continuous. All right, discrete data tended to be counts, okay? Like the example that I talked a bunch about was the number of cups of coffee I have per day. Or there could be another example, the number of children I have. So for example, you might hear in the background, my son is waking up from his nap and my beautiful wife has got him. But so the number of children I have is a, excuse me, discrete variable. Now what continuous is, these were measurements of some type. Okay, and this could be something like how many hours of TV you watched last night. Okay, so discrete and continuous, difference being that they're counts and measurements. So what we're going to learn and what we're going to talk about today is we're going to talk about ways to summarize data, okay? And the ways we're going to talk about first is we're going to talk about something called frequency. This will be the main topic of today. And then we're going to move into visual representations of data. And I will be honest with you all ahead of time. Today's lecture tends to be a little dry, just because a lot of the stuff I'm going to talk about, many of you know how to do, have seen before, or if you haven't, it's also very easy to understand. So stick with it. You know, don't get discouraged with the class when you're thinking, oh, this stuff is too easy. This is kind of boring. Class gets very different after this lecture and next lecture. But the stuff we talk about today, though, is a building block towards future study. Okay. So our first topic today is going to be talking about how you organize this qualitative data. Okay, so this data that is categorical. And to begin, what we need to do is we need to set the stage with some definitions. Okay, and this is the main topic today, is going to be this topic of frequency. So frequency uses three definitions that you're just going to hear me say over and over and over and over today. All right, so the first one is a class. Okay, so this is one of the categories for which data is classified. So the way I like to think of a class is it's the groups you put data into. Okay, it's the different groups data fall into. The next is this frequency, so we're defining frequency here. So frequency is the number of observations in the data set falling into a particular class. And what frequency is counts. Okay, counts in each class. And so what I have today for us, you'll see in a little bit, is I have some examples I walk you through, and then I have some examples where we're going to get to do them together. Next, we have this thing called relative frequency. And relative frequency is the class divided by the total number of observations in the data set. So the way I like to think of relative frequency is there a proportion in each class. Okay. And I'm just curious, I'm gonna just pause for a second before I go on. I tried to get this mic that doesn't pick up background noise. Do you guys just hear me talking, or do you hear any of the background, maybe my child screaming right now?
I hear the background.
You do, you hear my little guy going at it?
It's okay.
Yeah, no, I mean, what can you do, right? Like,
Yeah.
you know, you have childcare. My poor wife, this is my like time away from it. So, but I'm glad you can barely hear it. I'm just curious, does anybody in the class have kids at home with them? Ten? Come on. Really? But it's hard with kids. So I get it, especially with you as being students, you know, I get it. But anyways, they are a life changer. So if anybody's thinking about having kids, they definitely change your life in a good way, Anyways, let's go back to the lecture here. All right, so we have class, which is the groups that you fall into. Frequency is the counts, and relative frequency is the proportion of each class. I'm gonna show this concept of relative frequency as a proportion, but you can show it as a percentage if you have to, okay? All right, so then what we're gonna talk a lot about is this concept of a frequency distribution, or sometimes I'll refer to it as a frequency table, okay? And the first one I'm gonna show is for this qualitative data. And what a frequency distribution of qualitative data is, it's just a listing of the distinct values, all right, and their frequencies. So when I say distinct values, what I mean is the distinct classes or the groups that the data fit into, okay? And remember, the frequency here is their counts. All right. So here will be the first example that we're gonna have. All right, so political party affiliations and students in an introductory statistics class. So what I'm gonna have here is I'm just gonna have a data set of the parties each student belongs to. All right, so when you think about political parties, what are the two main political parties in the United States?
Democrat and Republican.
Yeah, all right. And then but then the next question is, does everybody classify themselves as a Democrat or Republican?
No.
Nope. So if you look here, what I have here is I have a list of each student. So each data value or each observation here, each one represents a single student. And you can see some students say they belong to the Democratic Party, and some students say they belong to the Republican Party. But then what about, is there a third list there that students might belong to? Yeah. So what I'm getting at here, going back, is I want to take this data here. I want to take this raw data and I want to summarize into a frequency distribution too. So if you look back, and I'm going to scroll back for a second, the first thing I need to do is figure out the class, okay, the categories for which I'm going to put data into. So the different classes I'm going to have, all right, well, you're either a Democrat or you're a Republican, or you belong to the other party. Okay, maybe you're libertarian or independent here. Okay, so those are the classes that I have for each. Now to construct this frequency distribution I'm talking about, you're going to list the distinct values of observation in the data set in the first column of a table. So what I mean by this distinct value, is you're going to list the classes. All right, so you're going to list that Republican, Democrat, Independent. And then for each observation, this is the way if you wanted to do it by hand, you're going to place a tally mark in the second column of the table or row to for the appropriate distinct value. What I mean here is you're going to count the number of students in each class. All right, and this here is just changing that tally mark to an actual number. So really, it's super easy. Basically, this is a hard way of saying, looking back here, just count how many Democrats there are, count how many Republicans there are, and count how many others there are. So what I'm going to do here is I actually just did this for you and show you it as the table here. So this party here, these were the different classes that we said we were going to have. You're a Democrat, Republican, or other. And what this tally mark represents here is every time I would go through, I'd say, okay, the first person is a Democrat. I put the tally mark here. The next time I count a Democrat, I put another one, and so on, and so on, and so on. So this here, this frequency then, is just the counts in each group. So what we did here was we took this raw data set here and we just summarized it into this nice table. Okay, this right here is this frequency distribution or frequency table. Very, very straightforward. What do you guys think? Yeah, it's super straightforward. The next thing I want to say is something about this concept of relative frequency distribution. So there's no context like behind some of these numbers. Like for example, if I just were to say to somebody, hey, there are 9 students in my class that say they belong to an other political party. You know, there's no context behind that in the sense that, well, are there 10 students in your class? Are there 100 students in your class? So we next introduced this concept of relative frequency. And all the relative frequency of qualitative data is the listing of the distinct values and their relative frequencies. So a relative frequency distribution, what it does here is it goes back to this table basically, and it adds a new column called relative frequency to add a little bit more context for us. All right, so to do this, it's really easy. You just obtain the frequency distribution of the data. We got that. And then to find the relative frequency of each, we just divide the frequency by the total number of observations. So what we're doing in this step is just making that relative frequency column as a proportion. Right, it's pretty straightforward for that. So to do that, here, all you're going to do to add that relative frequency column is you're going to take for the Democrats, there were 13 Democrats, and you are going to divide it by the total. So you divide the counts of each class by the total number of observations. And the important thing is when you do this, this is really important. You have to make sure that if you do this in such a way that you round values, they have to sum to 1. okay, as that represents 100%. Also pretty straightforward for that. Yeah, so it's like really all that's going on here is to make these tables, okay, what you're going to do is you're going to take your raw data set. You're going to divide them up into classes, Democrats, Republican, other. Then initially, you're just going to count how many fall in each class, all right? And then to find the relative frequency, just take the totals in each class and then divide by the total count of all the students. And that's it. Very, very straightforward. All right, what we want to do now is we want to talk about how you take your frequency table and show it visually. So show the frequency table visually. And there's two ways we're going to talk about this. I'm going to do really briefly, this concept of a pie chart. And then we're going to spend a little bit of time on bar charts, and we'll do an example with all of us in class using bar charts. But how many people in here have heard of pie charts before? Or have seen them? Yeah, they're pretty straightforward. And actually, how many people have seen or constructed a bar chart before? Yeah. So we'll go through this. We'll go through this really quickly. All right. So the first way you're going to take this frequency distribution and this frequency table and show it up as a pie chart. And all a pie chart is a disk divided into wedge-shaped pieces proportional to the relative frequencies of the qualitative data. So really what you're doing is you're just taking a disk. That's supposed to be a circle. Sorry. Okay, but I was trying. And what you're going to do is you're going to cut this up so that the area is proportional to the individual classes. Like this would probably represent 50% of the area, this 25%, and this is 25%. That's really how you do a pie chart by hand. All right, so all you're going to do to construct this is obtain a relative frequency distribution by applying the procedure above, the one that we did. So to find this relative frequency, you're going to divide the disk into web-shaped pieces proportional to the relative frequencies, and then you're just going to label the slices with distinct values and the relative frequencies. So let me show you the pie chart for this. And this was actually, this I made in Excel. But you know, when you look back at the table here, 45% of the class said they were Republican. So this pink area here is 45% of the circle. There were 32.5% of students said they were Democrats, and 22.5% said they were other. So just these wedges represent that proportion of the area of the circle. Very, very straightforward. All right, the one visual we're going to spend more time on here is this bar chart. Okay, so there's two types of bar charts you can make. You can make a frequency bar chart, or you can make a relative frequency bar chart. Okay, both procedures are both the same. The only difference is how you label one of the axes for this. So a bar chart displays the distinct values of quantitative data on the horizontal axis and the relative frequencies or percentages on the of those values on the vertical axis. So when you go to construct a bar chart, you're always going to draw the first quadrant of the Cartesian plane, all right? And what's going to go along the horizontal axis here are the different groups or classes that you have. And what's going to go on the vertical axis here is the frequencies, or if you want to do a relative frequency. All right. So the relative frequency of each distinct value is represented by a vertical bar. So what you'll do is you'll draw a bar for one group to go up to whatever the count was. All right. And then you'll do that basically for each group. And we'll do an example of this actually in class where I'll have everyone be part of a poll in a second, okay? And the bars should be, this is the only important thing about a bar chart, should be positioned so they do not touch each other. Okay, that's the one important thing about bar charts. So bar charts have a space between groups. Okay, that's important. So I'm not going to walk through this step procedure here exactly. I'm going to show you an example of this using our Republican, Democrat, and other data, and then we'll do one with all of us. All right, so this is what the relative frequency one looks like. So if you remember, it was 32.5% said they were Democrats. That's where this goes over to here. You can see it on the bar chart. So these tick marks represent a relative frequency. And you can see here along the horizontal axis, we have all our different classes or different groups. And the Republicans, it looked like they said was 45%. And you can see up to the top here, that's where this bar chart goes here. And 22.5% said they were other. And that goes right there as well. Straightforward to make these? Yeah, I think it's very easy. All right, so here's what I want to do. I just want to do an example for us. So instead of me just showing you slides, I want us to collect some data in this class and actually draw it by hand. Okay, so I have this poll here. So it's football season starting, okay? So I have a poll I want to talk about your favorite New York football team. All right, so I'm going to launch this poll, and if everybody could participate this who's paying attention to the lecture, I'd appreciate it so we can collect some data. So here's my question. Who is your favorite football team in New York? So it's the Giants, the Jets, or neither. We don't count the Bills.
Professor, I have a question.
Yeah.
Do you want us like writing our own chart, like making our own chart?
Yeah, we're gonna do that together with this data that I collect here.
Okay.
I'm gonna write the numbers down. There's no love for the Jets here. So I'm gonna end the poll. So this is what our class had here, okay? This is what people, can everybody see the results? Okay. So what I wanted to do here, basically, this is what's going on. I wanted to take our class and I wanted to divide them into different groups or different classes. All right, so this is the groups you either fit into. You were a Giants fan, you were a Jets fan, or you were neither. And what you see here, just the results from the poll are the frequency, or they have the counts of each. All right, so 9 people said they were Giants fans. All right, I'm actually a big Jets fan, so I'm gonna go in here. All right, Jets are actually pretty terrible. They are every year, okay? And then there were 13 people who said neither. And I'm just curious, for the people who said neither, is it like you like a different team or you just don't like football? I'm just curious.
Don't watch it.
You don't watch football? Yeah, I don't blame you. I like it. It's a big distraction, personally. Every Sunday is just something to do. All right, so if you look here, we have the total percentage or the total number of people who participated in this poll. All right, it was 25. So this is our total. So next what I want to do is I want to take this and I want to write what is the relative frequency. Okay. So can someone tell me how you find the relative frequency again? For, say, the Giants, what would I do? Yeah, so the relative frequency, you would take 9 and divide it by 25. Okay. I believe if you did that, you would get 0.36. Did I do that correctly? Yep, thank you. Then find the proportion of people who said they were Jets fans, you would take 3, you would divide it by 25, you would get 0.12, I believe. And then to find the proportion of people who said they were neither, you would take 13, divide it by 25, I believe you would get 0.52. Yeah, thank you. And if you check here, we didn't have to round anything, actually, it worked out perfectly. This sums up to 1. So this right here, this with the classes, the frequencies, and the relative frequency represents an entire frequency / relative frequency table. All right, table or distribution, depending on how you want to call it. Okay. But you know what? Maybe people who don't like football, you should just become Jets fans. All right. As you can see, we need all the support we could get here. All right. So now what I want to do is I want to show a visual representation of this. Okay. So what I want to do is I want to show a frequency. Yeah, you can ask a question.
Where do you take the 9 and the 3 from?
So where did I get the 9 and the 3 from? Mm-hmm. Yeah, that was the results of the poll. So 9 people on the poll said they were Giants fans. 2 people said they were Jets fans, and I'm actually a Jets fan, so that's where I put the 3 from. So you can see, can you see the poll results right there on your screen? There's the 9 people who said they were Giants, and so on. Does that answer your question?
Yeah.
Okay. All right, so the visual, this right here, this 1, it's the sum of this. You just have to make sure that these sum to 1 to represent 100%. It's just a help check to make sure you got it correct. Like this 25 was the sum of this right here. And if you sum 0.36 and 0.12 and 0.52, you get 1. Make sense? All right. So now I want to show a visual representation of this with a frequency bar chart. All right, so when you draw a frequency bar chart, you draw the first quadrant of the Cartesian plane. And along the horizontal axis, you're going to put the different groups or classes. So here are the people who said they were Giants fans. So I'm going to put a little bar tick here to represent that. With bar charts, you have to remember there's a space between classes. So the next group we had here were the Jets fans, and then people who said they were neither. And then what we're going to do, because I tell you to make a frequency bar chart, along the vertical axis, you're going to put frequency. And what I'm going to do is I'm going to go by 5s here just to make this a little bit easier. 5, 10, and 15. All right, so the Giants fans, what you're going to do is you're going to draw a bar up to approximately where 9 is. And this bar here represents the number of Giants fans. Now there were only 3 Jets fans. Ah, that's sad. I don't blame you. They're going to be terrible this year. So that bar is going to represent the Jets fans. And then you're going to draw a bar up to the number 13. And that's going to represent the number of people who said, nah, neither. I don't like football. So here's what we did. We took the class, we did a little bit of a poll, and we got the frequency, we got the counts of each, and then we got the proportions. All right, so we summarized it into that table, and then we summarized it into a nice little bar chart. Okay. Not too bad, easy peasy. All right, let's move on to something a little bit harder, but it's actually not that much harder, okay? So we'll just get through the next part and then we'll actually be right about at our break time. All right, so now what I wanna do, we talked about qualitative data. I wanna talk about summarizing quantitative data, okay? So this is data that is a measurement of some type. Okay, but the thing about quantitative data, if you remember, there's two types of quantitative data, okay? There's discrete, and then there's continuous. Okay, so you're gonna have to, how you summarize it and show it between discrete and continuous, there's gonna have to be a little bit of a distinction. All right, so here's an example here. This will be one of the first ones we work at, okay? So I have, I talked to 50 households. So this is our sample size. Right, and if you remember from last class, we used lowercase m to represent sample size. And I asked the number of TV sets in each household, okay? So it looks like there's a lot of people who said they have one TV. I have only one TV in my household. And then what does it look like the most number of TVs are in a household? Yeah, like crazy. Yeah, look, some people are saying they have 6 TVs per household, okay? All right, so here's what I want to do. I want to, is there any 7s in here? No, we'll see. I don't think there's any 7s in there. I could be wrong. Okay. Yes. All right, so we have this data value here, okay? Or a variable. All right, and what it is the number of TV sets in your house. Okay, is this data value here, okay, the number of TV sets in a house, discrete or continuous, just out of curiosity? Is it a discrete variable or a continuous? So is it a count or a measurement? Yes, yes, exactly. You guys are right. It's a discrete. Okay. All right, so what I want to do is I want to talk about how you take this raw set of data of 50 data values, okay, and summarize it now into that frequency table. Okay, so the thing about this is when you have quantitative variables, how you group your data is the most important part, okay? So there's a little difference between how you do this for discrete and how you do this for continuous. Okay, there's a slight difference in how you do this, okay? And the two ways you do this is you have to choose a grouping method to group your data by, okay? And the two ways, the first way you do it is what's called a single value grouping method. And this is when you use with discrete data in which there are only a small number of distinct values. So for data that has counts of some type. Okay. And if you look back here, our data here has a small number of possible values. Okay, it has the values 0, 1, 2, 3, 4, 5, and 6. That's it. Those are the only values here. Right, this other way we'll do it is what's called limit grouping. All right, this limit grouping is just slightly more complex. It just requires an extra step. Okay, and this you use when the data are expressed as whole numbers and there are just too many distinct values to employ single value grouping. And generally we're going to do this when we have continuous data. Okay, so even though this says it works for whole numbers, it can actually work for all real numbers. So it works with data with decimals too. Okay, so going back to this, we have these counts. So this is discrete data, as you all said. So I want to show you how to use this single value grouping to put this in a frequency table. All right, so to use the single value grouping, all right, frequency and relative frequency, all right, for this over here is shown for this example with the number of TVs. So all you did was your classes or your groups are the possible values. Okay, so you had the households that had 0, 1, 2, 3, 4, 5, and 6. And then all you have here were the frequencies, were the counts of each. And then from those counts, you can very easily find the relative frequencies, which are the proportions of each. All right, so like for example, this is shocking actually. Of the 50 households, there was only one of them that had 0 televisions. So this here was this 1 divided by the 50. This right here, this relative frequency here was 16 divided by the 50, and so on. So basically, just to recap here, if it was single value, okay, all you did was you list the different classes, and count how often those values appear. All right, piece of cake, super straightforward. All right, let's change it now and do something that's a little bit different, okay, a little bit more difficult. So what you see here listed is I have these 40 short-term investments. I don't know, they could just be, let's just call them bonds that you buy, okay? Right, those are, you can buy short-term bonds, okay? And what this is days to maturity. So what that means is like when you buy the bond, how long until you can cash your money out? Like how long does it take for you to get your interest on that bond, okay? So the data here is days, all right? Is days a count or a measurement of some type? So is it discrete or continuous? This is where it gets a little confusing. Yeah, I agree with you guys in the chat there. Yeah, this days is a measurement of time, okay? So the number of days here is a continuous data value, okay? So if you look here, there are just too many distinct different values, okay? 70, 64, 99, 55, 64, 89, 87, they're just all over the place. So what you might not want to do here, what might not make sense is using this single value grouping, okay? Instead, what we want to do is we want to introduce this limit grouping. And the way limit grouping works is you set what's going to be called a class width and group values that fall inside a class width. And think of, when I say class width, what I'm really talking about here is a class range. All right, and that'll make more sense when I show you the definition. But another way to think about this is you want to group like numbers together. All right, so like what I mean by like numbers are maybe you want to group all the 30s together, group all the 40s together, and so on like that. All right, so the way you do this limit grouping is we're going to need to use these following terms here. All right, so we have what's called the lower class limit It's the smallest value that could go in a class. So think about it as the starting value. The upper class limit is the largest value that could go into a class. So think about it as the ending value. All right, the class width is the difference between the lower limit of a class and the lower limit of the next higher class. Okay, so think about it, it's going to be, so let me just write this down and I'll answer that question. It's going to be lower limit 1 versus lower limit 2 versus lower limit 1. So beforehand, I said originally I wasn't going to share my notes in the Blackboard shell, but it seemed like people would prefer me to do that. Is that correct? That I put these markups there for you? Fine. Gosh, everyone's saying yes. Yeah, I will do that for you. Okay. Let me just, you're welcome. I will just say one thing though. I understand it is fast. I get it. We're almost coming up on break and I got to get through like 50 slides in 2 hours. I get it. I get it. The only thing I would recommend you do is when I do an example like this, if you can follow along while I do it and write down, it's just good practice. That would be the main thing I would recommend. Also, I will be honest with you. I get that listening to me talk straight for 2 hours can be a little bit boring and monotonous. So if you want to write this stuff down as I do it, it might help you stay engaged and paying attention. Does that make sense to everybody? Okay, but I also get it, like if you're at home and especially like, you know, if I wasn't teaching and on the clock right now and I heard my child crying, I would have gone and helped my wife. But so I get it if you need to step away and stuff. So I will do this. All right, just to go back real quick now. The last thing here, we have lower limit, upper limit, class width, and then we have what's called the class mark. And this is just basically ways you can identify each class. You guys are welcome. I understand it's a weird semester with everything going on. I get it. So this right here, this class mark is also sometimes referred to as the class midpoint. All right, and it's just the average of two class limits. So the average of this and this, and it's just a way to identify the classes or write them. Okay, so here is the example of how you would do this class grouping, this limit grouping, excuse me, for this data right here. Okay, so we had all these different days. And what I wanted to do is I wanted to group like numbers together. Okay, so I wanted to group all the 30s together, all the 40s together, all the 50s, so on and so on. Okay, so you have a class lower limit and a class upper limit. And so you can see for the 30s, if you wanted to group all the 30s together, your lower limit here would be the lowest possible value in the 30, and the upper limit would be the highest possible value in the 30, which is 39. So what you would do then is after you'd say, okay, well, how would I do the 40s? Well, the 40s would be all the numbers that go from 40 to 49. From 50, the 50s would be 50 to 59. The 60s would be 60 to 69, and so on. And then all you would do is you use these tallies as you go through by hand as a way to help you count. Okay? So looking back here, what you would do is you just go through and you'd say, okay, the first value is a 70. I'd put a tally mark here. The second value is a 64. I'd put a tally mark here, and so on. You would do that as a way to help you. And I'll just do the next one. 99. I'd go into the 90s. And then all you do here is count your tally marks. I have 3 tally marks. There were 3 investments that had maturity dates in the 30s, 1 investment in the 40s, and so on. And then you can check, make sure you counted right. I have the 40s here. And then your relative frequencies are just, again, the frequencies divided by the total. All right, so it's basically, it's just the only extra step between what we were doing is you have to set up the classes. That's really the extra step here, okay? All right, can I just get through histograms here real quickly and then we'll take a break? Does that sound okay with everybody? Okay. All right, so the visual representation for this, for histograms, we use this when we have quantitative data. Okay, they use histograms. Just as a refresher, just recall qualitative data uses bar charts. Okay. And I'm going to show, I'm not going to read all of this verbatim, but I just want to talk about the key difference with the histogram versus a bar chart. Okay. So a histogram, what you're going to do is you're going to set up the first quadrant of your Cartesian plane, and you get your classes along the horizontal axis, and you get your frequencies, or your relative frequency, excuse me. Along the vertical axis. And if you look here, you go back to how we did our groupings here. Do you notice when one group ends here, the next group immediately picks up? Do you see that? Like as soon as you get out of the 30s, you go right into the 40s. As soon as you finish with the 40s, you go right into the 50s. So like the classes flow into each other, okay? They're continuations of each other. Whereas if you look back here, like the difference between Giants and Jets fans, okay? They don't flow, so we put a space between them, okay? Because Jets fans tend to be classy individuals and Giants fans tend to be unruly people, okay? So we have to have a separation there, okay, if that makes sense. And that was a joke, by the way. Just happens to be true, though. So the big difference here, when you're drawing your classes, when you go to draw the counts, the bars, they're going to build off each other. All right, so histograms are going to have no spaces between classes. Okay, that's the big important thing with histograms. Okay. And so there's a bunch of different ways you can visually show it or visually mark the classes. Okay, you'll see for single value grouping, we use distinct values of observations to label the bars, where we center them under the bars. For limit groupings, or this cutoff grouping, it can also be called, we use lower limits at the end of each bar to denote where one class ends and one class begins. And I'm going to show you an example of both of these in a second. Okay, so to construct a histogram, I'm going to skip this a little bit and just show you how to do it, and it'll make sense as I walk through the examples. Okay, this is the single value grouping histograms for number of TVs, okay? So this is a histogram for discrete data. So what here is you had your classes. So there are households that had 0, 1, 2, 3, 4, 5, or 6 televisions. And then you have your frequencies or your counts along the vertical axis. You can also do relative frequency instead. It doesn't matter. And this, if you look back here, you know, there was one household that had 0, there were 16 that had 1. So as you draw the first group, The number of households that had 0 TVs was 1. And then we put the 0 mark in the center of the bar. And then you go to the number of households that have 1 TV, you build the bar right off the next one, and so on and so on. And it's the same thing with the relative frequency if you use the relative frequency along the vertical axis. There's just one thing I really want to note here that's important. Just notice how the 2 histograms look. If I ask you to construct a frequency or relative frequency histogram, do they have the exact same shape? Like one looks a little bit taller, that's just because of marking, but do they have the same exact shape, these 2 histograms? Yeah, they do. Okay, and that's important, all right, to note or remember for this. All right, the subtle difference here now when you use this limit grouping, all right, for days of maturity. So what we're doing now is we're going back and we're taking either the frequency or relative frequency and putting it in a histogram. So just notice in the 30s there were 3, then in the 40s there were 1, and then in the 50s there were 8. With the limit grouping, you put the lower limit of the first class to mark one end, and then the ending part is the lower limit of the other class. So how many investments were in the 30s? There were 3. And then between 40 and 50 in the 40s, there was 1. And then there was 8 in the 50s. And notice at the end of each bar is the lower limit of each class. And that's how you just do a histogram here. In this case, discrete data, you center the value over the bars. Continuous data, you use the limits here. And don't worry, we're going to get to do one of these by hand in a little bit. All right, let's take a break. Is that okay with everybody? We've been going for quite a while. Going for an hour straight. So we're going to take a 5-minute break. We'll start back. Yeah, I'm going to get some coffee. Thank you. Ha, you remembered. That's funny. We're going to start back at 2:05. Okay, everybody, I'm going to go to get a coffee, and I'm going to check on the wife as well. All right, everybody, I'll be right back. All right, everybody. Let's get back. Let's finish this up. Can everybody, just a mic check, can everybody hear me again okay? Okay. All right, good. I took the advice. I got a cup of coffee. Now I definitely sound like I live in New Jersey. Got some coffee. But we'll finish up today. All right, so I went through this pretty quick right here, this whole limit grouping and constructing a histogram. So what I want to do now is I want us to do one by hand so you can see in practice. So a lot of times if the definitions and stuff in this class are confusing, as soon as you do an example, it's pretty straightforward, okay? All right, so I have this example here. So suppose you have this manufacturer of insulation and they randomly select 20 winter days and record the daily high temperature, okay? So temperature we know from last class, this is a continuous variable or data, okay? So what I want to do is I want to take this data and I want to do everything we just did. I want to make the frequency table, frequency distribution, and then I want to draw the histogram here. All right, so for a value like this, one of the first things I'm going to do to make this example easy is I'm going to take these 20 data values and just for us to make it simple to work with, I'm going to order the data right like here. Okay, so can everybody see the ordered data here just fine? Okay. So we have continuous data. Do we do the single value grouping? Or for this type of stuff, do we do limit grouping? Okay, yeah, thank you. So what we're gonna have to do is we're gonna have to do our limit grouping. So for histograms, the way I suggest to do a histogram by hand is do it in such a way that it makes sense. Okay, so make the groups, have them be, they have to have the same width, that's important, but do it in such a way that the groups make sense, okay? And now what also gets a little weird is you don't want too many groups and you don't want too few groups, all right? But if you look here, we had one winter day where the daily high was 12 degrees Fahrenheit, another one where the daily high was 58 degrees Fahrenheit. And then we have all these values in between. All right, can somebody in the chat offer me a suggestion for how we're gonna group these? Like what do you think the first group should be? Okay, Pamela, yep. So perfect, right there. So what we want to do is we want to group all the teens together, okay? Like the 12s, 13, and 14. So what we're going to do is we're going to say any value in the teens. Well, that would be all the values from 10 to 19. That's perfect. And then we want to go and count all the values in the 20s, all right? Because those are like values. So what would our net, yep, you got it right there. Then the next one would be 20 to 29. 30 to 39 would be the next one. 40 to 49. And then 50 to 59 right there. So we got the teens, the 20s, the 30s, the 40s, and the 50s. And now all you have to do is get the frequencies, and remember those are just the counts. So it looks like we have 1, 2, 3 of them here. 1, 2, 3, 4, 5, 6 here. 1, 2, 3, 4, 5 in the 30s. 1, 2, 3, 4 in the 40s. And then 1, 2 in the 50s. All right, so then you guys got to make sure when you do this by hand, if you look back, I said there were 20 winter days. So just make sure that you get this correct. So like 3 and 6 is 9, 14, 18. Yeah, it does sum up to 20. So it works out. So then the next thing you're going to do is you're going to get your relative frequencies here. So this is just exactly 3 divided by 20 for this group, which is 0.15. 6 divided by 20, is 0.30. 5 divided by 20 is 0.25. 4 divided by 20 is 0.20. And 2 divided by 20 is 0.10. And what did all these relative frequencies, what did I say they had to sum up to? Yeah, and they do. If you were to sum these up, they would sum up to 1. Yes, I am doing it off the top of my head. Actually, there's a little trick to it, right? So like actually what I'm doing in my head, if you're just curious, the way I do it is you multiply 20 by what to get 100%. So 20 times what gets you 100? Okay, so all I'm doing is 3 times 5 is 15 and just writing it as a decimal. 6 times 5, writing it as a decimal. So does that make sense of how I did that just really a lot quicker? Yeah, it's just a number trick. Yeah, I always used to tell people that being good at math is actually just being good at knowing the tricks. Because like nobody sits there and does, long division like this, going back, how many times does 20 go into 3? They don't do that. They do the tricks to help you get this. Okay. All right. So what I have here is I took my data. I did this limit grouping. I put them into different classes. I got the frequencies, I got the counts, and then I got the relative frequencies. Okay, so let's draw now the histogram of this. Okay, we'll do this together. All right, or you can watch me do this. Okay, so let's do a relative frequency histogram instead of a frequency. Okay. So you're going to draw the first quadrant of the Cartesian plane. Okay, and what goes along your horizontal axis is your classes. So you're going to start the class at 10, and then you're going to use the lower limits as the markers. Okay, so between 10 and 20 is where you'll put the teens. Between 20 and 30 is where you'll put the 20s. Between 30 and 40 is where you'll put the 30s. Between 40 and 50 is where you put the 40s. And between 50 and 60 is where you'll put the 50s. Okay, so we're doing the relative frequency. So looking back here, I'm going to use these values right here. So it looks like my lowest is 0.10 and my highest is 0.30. So I'm just going to make it simple on myself and do the scaling like this. 0.10, 0.20, and 0.30. Okay, so the first group. Okay, if you look back here, the relative frequency was 0.15. So that's the first group. Then the next group, okay, there were 1, 2, 3, 4, 5, 6 of them. So it was 0.30. So the 20s, you're going to build the bar off like that. The next group, the 30, there were 25%. So I'm going to go to 25% like this. In the 40s was 20%. So here's 20. I'm going to go over. And then finally, the 50s, there was 10 like this. And that's how you did this grouping using the limit grouping, and then draw the histogram of it. So now that you've seen me do an example of taking this data and putting a histogram of it, do you guys think you could do one on your own eventually? Okay, so actually your, when you go to look at your first homework assignment, you're gonna have to do exactly what I just did here, okay? So you're gonna have to do the limit grouping and go from there and draw the histograms and stuff. Okay, I want to talk now briefly about distribution shapes. Okay, and histograms in our class are going to be really important. So the shape of histograms will tell us a lot about the data. Okay, because what we're going to notice is histograms that have certain shapes have very specific properties. Okay. The first one we'll talk about is the normal distribution, this type of shaped histogram. Okay. And this is going to be the most important for our class. And the key defining features of this type of histogram is that the data is centered at the middle. So if you look at this histogram here, the highest point of it is at the middle, okay? And then what you're going to notice is less data to either side. So as you get away from the center, the amount of observations fall as you get above, and the amount of observations fall as you get below. Let me give you an example of something in the real world that would follow a normal distribution. Now, if you look at the height of adult males in the United States, okay? I'm about 5'9". That's how tall I am. Would you guys say I'm about the average height for adult males, people who are about 5'9"? Think that's about the average height? Oh, I got one person. Okay. Yeah, I'm about average height. Okay. I actually lie a little bit on my driver's license and say I'm 5'10", but I'm actually really 5'9". Thank you for that laugh. Yeah, so what I'm getting at here is most people in the United States, okay, are around this height, okay? As you get taller and taller and taller, like, are there people in the United States who are 6'4", 6'5", 6'6"? Yeah, but are there as many people in the United States who are 6'5", 6'4", 6'6", as there are who are 5'9", 5'10"? Yeah, no, as you get taller and taller and taller, there's less people. And it's the same thing on the other side too, right? Like adult males, there are adult males who are 5'5", 5'4", 5'3", but the number of people who are of that height gets smaller and smaller as you get further and further from the center, okay? All right, this distribution, this is what we're gonna study in section number 4 of our class. And we're gonna spend a lot of time talking about the properties of this, and there ends up actually being a lot of really cool statistical theories from this. Okay, then you can have what's called right skewed and left skewed. So what right skewed is it looks like it has a tail that shoots off to the right, and left skewed, it looks like a normal distribution, but it has a tail that shoots off to the left. So an example of right skewed distribution real quick would be if you were to ask people the hours of TV they watch per night. Okay. The least amount of TV somebody could watch per day is 0. The most somebody could watch per day theoretically is 24 hours of TV. You know, the vast majority of people, you know, consume television in a reasonable amount. I don't know, between 0 and 3 or 4 hours a day. But then there are a lot of super television watchers who watch all day and have nothing else to do. Something that's left skewed you might look at, it would be hours of sleep people get per night. Okay. What's the least amount of hours of sleep you could get per night? Yeah, theoretically it's 0, right? And then, you know, the most, you know, let's just say reasonably, you know, the most that you're going to get per night is 12 hours. They say you should get 8 hours, okay? So the vast majority of people, if you ask them how many hours of sleep they got per night, you know, they're going to say something like between 5 and 12, you know, but then there are some people who each night they get less than 5 hours of sleep, but there's not that many of them, okay? And let me tell you, if you want to ask about people who get less than 5 hours of sleep a night, just talk to people who have a newborn, okay? Let me tell you. That was a joke, by the way, but true, Okay, so this is the one we're going to study a lot. We'll also look at these distributions quite a bit in our study as we go forward. But there are two other types that you would see in the real world. There's a bimodal distribution, and what that looks like is two normal distributions thrown together. And then you have the multimodal one, which what this looks like is just up, down, up, down, up, down, up, down. So like maybe no real pattern. All right. These occur less often, but just when you see them, you know, like in the textbook or later on in class when we look at data, this is what we'll classify them as. All right, but we'll stick mostly with skewed distributions in this class and a lot of normal distribution stuff. All right, I want to get through an example now about reading histograms. All right, you have a problem like this on your homework. So, you know, seeing this will help you answer that homework question. Okay, I always put something like this on the first exam as well. And this problem is actually at first can be a little bit trickier than it seems. Okay, so here's the problem. The histogram above shows the level of cholesterols in milligrams per deciliter of 200 people. Okay, so what's important that you see here is that the sample size for this is 200 people, okay? But look along the side here, okay? Is this a frequency or a relative frequency histogram? Yeah, so these are not counts, these are percentages. Okay, all right, so they're percentages, not count. So the first question is this: how many people from this chart, okay, have a level of cholesterol between 205 and 210? All right, so just to answer this question, you're gonna go here, here's 205, here's 210. So it's all these people right here. Okay, so you're right about that. So let me just say this. So you go right to the top, and the relative frequency is 0.2. So that's 20% of people. All right, but I'll tell you this though. If you just put 0.20, you'll get the question wrong, actually. Okay, this is why you have to be very careful about this. Did I ask you what proportion or percentage of people, or did I ask you how many? Okay, Tora has it. How did you get 40 people? You're right. And Leonardo has it. If you guys want to type how you got it. Yeah. So what you would do is you would take the proportion of people, which was 20% of people, and you multiply it by the total. So the number of people who have that, you would take 0.20 times 200 would get you 40 people. So that would be the correct answer, okay? So just I'll be honest with you, on your first exam, I probably will try to trick you up a little bit like that, so you're getting a warning now. So just read these problems very, very carefully. Okay, the next one says, how many people have a level of cholesterol less than 205? So here's 205. To be less than that would be this one and this one. So this group represents 5% of people. This group here represents 10% of people. So that is 0.15. But then to get the number of people, you'd multiply that by the 200. And I believe that would get you, 30. Exactly. All right, next question. Now I'm got to be careful of the wording. What percentage of people have a level of cholesterol more than 215? So here's 215. So it would be these people and these people right here. So this one looks like 0.25, and this one looks like 0.05. So as a proportion, it's 0.30, but just be careful. I asked you for a percentage. So you just have to change that to a percentage. All right, finally, last one. How many people have a level of cholesterol between 205 and 220? So it's this group, and this group, these three right here. This up here is 0.35. So this would be 0.20 plus 0.35 plus this group here, which would be 0.25. What do you get? Do you get 0.80 when you do this? Did I do that math correctly? Yep, thank you. So you would take the 0.80 times the 200 people, and you would get 160 people. All right, I think you could, I know I went to that pretty quickly, but do you think you could handle something like that on the homework? Okay, I just want to warn everybody, just please, when you do the homework and especially on exams, make sure that you read it very carefully and like, they ask how many people. So you want it as a number, not as a proportion or as a whole number, okay? All right, I'm gonna skip this one here just for time constraints and move on just a little bit. And I wanna talk real briefly about population and sample data and how they're related to each other, okay? So we've talked about this before. When you have population data, these are the values of a variable from an entire population, so it's complete info. When you have sample data, they're values of a variable from a sample of the population, so this is just incomplete info. And remember, it's just a subset of the population. All right, so when you're looking at population data, the distribution of the population data is called the population distribution or the distribution of the variable, okay? This is what, whenever you have a population, what the actual full data distribution is. Okay, but when you just have a distribution of sample data, it's just called a sample distribution. Okay, so why am I going through this? In the real world, it is often hard, often difficult to collect population data. Like, for example, what I mean is, suppose the government wanted to estimate how tall adult males were in the United States. Okay, so the government wants to estimate, for whatever reason, how tall adult males are in the United States. Do you think it's possible for the US government to contact every single adult male in the United States and ask them how tall they are? Yeah, there's just like no way they could do that. It's too time consuming, too expensive. So absolutely, Pamela, no, they cannot. All right, so often what we do is we use sample data to estimate population data. Or more specifically, what I'm talking about here is we use a sample distribution to estimate a population distribution. All right, so here's an example of what this is, what this might look like. Okay, so suppose, okay, that we know this, okay? And what I have here is I have the population distribution for household size in the United States, okay? So this is the actual population distribution. So the reality is this probably cannot be known. Like there's no way the federal government, even with the census, even though they try, to know exactly how many people live in each house, okay? It's really hard to, all right? But let's just imagine that this is the real population distribution. All right, when you look at this population distribution and this histogram of it, how would you classify the histogram based on one of the 5 ways that I talked about earlier? So would you say the histogram looks multimodal, bimodal, left skewed, right skewed, or normal? Yeah, I agree. So imagine you're a researcher, okay? And you want to estimate estimate or figure out what the distribution of people living in a household looks like, okay? So what I have here next to it in the right, in this orange type of histogram look, is I have the results from 6 different samples, okay? Okay. Now, when you look at these results, okay, and look at them real carefully, okay, do these results, did any of my sample data look exactly like the population? Like, yeah, exactly. Even this one, does this one look real close to this? It looks really close to it, right? But it's not exactly the same. And then if you look at this sample, okay, this sample is not exactly the same as this. This one is not exactly like this, and so on. But does each histogram kind of closely show what the distribution of number of households there are and the number of people in households in the United States? Meaning, are they pretty close? Yeah, I agree. Yeah, kind of. Yeah. So this is what we're seeing here. A sample distribution does a good job estimating or approximating a population distribution. Okay, and that's what we use statistics for and sampling for. Like there's no way maybe the federal government could actually figure out the number of people who live in each household, maybe even outside of a census year. So what they'll do is they'll say, okay, look, let's just take a sample. And each histogram does a really good job of showing or estimating the real population distribution. What we're seeing here is all of these histograms are also right skewed, with the vast majority of people living in a household between numbers 1 and 3 in almost all the cases, which is exactly what we're seeing up here. All right, so for a simple random sample, the sampling distribution always will approximate the population distribution. And this is a key concept right here, and this is kind of intuitive what you would think. The larger the sample size, the better the approximation tends to be. So in statistics, it's always going to be kind of a rule of thumb. A larger sample size is always better. Okay. I got 15 minutes left, so I really just want to quickly end class talking now about 2 extra ways, and it'll be real quick, for summarizing a data set, okay? One is called a dot plot, and one is called a stem and leaf plot. And so just like a histogram, it's just another way to visually represent a data set. All right, so we'll start with the dot plot, okay? And a dot plot is a graph in which each observation is plotted as a dot, obviously. So each data value is a dot. At an appropriate place above a horizontal axis, okay? And this horizontal axis is actually just kind of be a number line. And observations having equal value are just stacked on top of each other. So equal values, dots on top of each other. All right, so the way you do this, it's just very, very simple. You draw a horizontal axis that displays the possible values of your data. Okay, so this is your number line. Okay, you're gonna record each observation by placing a dot above the value. So place a dot above value for the data. And then just label your axis. I mean, that's it. It's incredibly straightforward. So like, here's an example. So this is a dot plot, and what I have here is I have data, prices in dollars of 16 DVD players. Okay, and I put this up here. Okay, does anyone even buy a DVD player anymore? But this is the data that I had. And this is how you would show the dot plot of it, okay? You would start with the number line, relevant to the data, okay? And then, so look, you look at the prices of these are expensive DVD players, okay? You know, you're trying to figure out where the lowest value is. It looks like we have some values around 199, maybe a little bit lower, 197. And it looks like the highest value is 224. So you just set a number line up relative to that. And then you just go, okay, my first value was 210. I'm gonna put a dot there. My next value was 219. I'm gonna put a dot there. 214. So I'm gonna go to 214 right there, and so on. 197. Make sense what I'm doing? And then when you get to another one that has 219, yep, that's it. So I'm just plotting the dots. That's it. 199. I got another 199. So when I have values that are the same, I just put the dot above it. So the 230 is just a continuation of the number line. So the number line you set in such a way that it makes sense to you, okay? So instead of saying, starting it at like 197 and going to 224, I just went to 190 and 230 just so it looks a little cleaner, that's all. So 208 and so on. Well, you get, it depends on the mood I'm in. That was a joke, that was a joke, okay? No, you won't get the, I always tell that, like on exam days, if I'm having a good day, everybody will score higher, but that's just a joke. That's just a joke. No. So generally what'll happen is you'll notice on your homework, I have the number line already set up for you. You just have to fill in the dots. Okay. All right, so just real quick, this is from our previous example. I'm just gonna do the first couple so you can see one where the dots aren't put up here. So this was the daily high temperature example. So I have my number line here, it's starting at 10 and goes to 60. So like the first value, 12, I'd go to 12 on the number, on the dot plot, put a dot. 13, put a dot. 17, 15, 16. Make sense how I did that? Pretty straightforward? Okay. And then you could just fill out the rest, but I won't, with the time we have left, I won't do that. All right, and then the last thing we have today is this stem and leaf diagram, okay? So the stem, so repetitive numbers, like let me find, so 24, so you'd put 24, and then when you get to 24 again, you would just put a dot above it, okay? So repetitive numbers have the dots above it. Yep, okay, no problem. Yeah, just like you see here, like repetitive numbers, the dots go above it. Okay, the final thing we're gonna talk about today is stem and leaf diagrams, or sometimes they're just called stem plots. So what you're gonna do is you're gonna take your data and you're basically gonna set up a table, okay? And your table is gonna be divided into two parts, what's called a stem. All right, this is consisting of the rightmost digit of your data and then a leaf, okay, for your data. Or excuse me, this is supposed to be, sorry, consisting of all but the rightmost data. Forgive me. So this is a little bit of a typo there, left value or values. Sorry, misread there. And then basically what you're gonna do is you're gonna take your data and you're gonna break them up into stems and leaves, okay? All right, so it's a little weird, but it's once you see an example, it's actually super straightforward. So I'm not even gonna read these steps. You can go back and read these. I just wanna show you how it's done, because I think that's a little bit easier. Okay, so here is the example of our days to maturity. All right, so this were the investments example, okay? So notice how they're all 2 digits. So the first digit of every number is the stem, and the second digit of every number is the leaf. So what you do here is you set up your columns, you have stem, and you have your leaf. So when I go to the number 70, it has a stem of 7 and a leaf of 0. Okay, so I cross that one out. As I go across this or go down, when I get to the value 62, it has a stem of 6 and a leaf of 2. Now when I get to the number 75, notice how I already have a stem of 7. That stem gets a new leaf. It has the number 5. 57 has a stem. The first digit is a 5. The second digit is a 7. 51, I already had the 5. Now I put the 1. Does everyone see what I'm doing there? And then all you do here to finish is you just sort the leaves. Okay, you just put them in ascending order. All right, there's ways you can do this a little differently. Like for example, this was easy because each value had only 2 digits. All right, but if you remember, the leaf here is everything but the rightmost digit. So if you have something that has 3 data values, okay, only the last digit is the leaf. So in this case, the first 2 digits would have to be the stem. So like when you see a value of 210, the first 2 digits would be the stem, and then the leaf would be the last digit, which would be 0. And just so we can see a full example of this, I just want to go and do that temperature example. All right, and just showing the stem and leaf of this. Okay, so you have this data set. These are all just 2 digits. So your first data value of 12, it has a stem of 1 and a leaf of 2. When you go to 13, the stem is 1, so it gets a new leaf of 3. When you go to 17, stem of 1, leaf of 7. See how I'm doing that? Now when you get to 21, you have a stem of 1, or a stem of 2, excuse me, a leaf of 1. When you get to 24, you have to put the 2 4s, okay? If there's repeat values, it gets 2 leaves, okay, separate. And then 26, 27, 27. Now you go to the 30s, gets a new stem, leaves of 3, 2, 5, 7, and 8, like this. Now you get to the 40s, it has a new stem of 1, 3, 4, and 6. And then when you get to the 50s, the stem of 5, the leaves of 3 and 8. And that's how you do the stem and leaf. What's incredibly interesting about a stem and leaf is if you look at this, what I'm doing is I'm just drawing boxes around the leaves. This looks like the sideways histogram of the data. So I'm just going to quickly scroll back real quick. This is what our histogram of this data looked like when we did it by hand. If you were to flip this on its side, that's exactly what you see. Okay, but it's just flipped sideways, and it actually contains the numbers. All right, class, that's our lecture for today. Whew, we made it. So what I'm going to do, I'm going to stop the recording here, and then I just want to talk about your homework again real quick, and then we'll call it for today.